Okay, welcome to the rest of you who just joined us, Jude, Junlei, and Kiranpreet. Okay, I've just started the lesson about 2 minutes ago on the dot at 7:30, and I'm replacing your regular teacher for today only. So bear with me as we go through this topic, diffusion. Okay, so you might be expecting a few more coming, but I do not have time to wait for them as all our times are precious. So let's begin with what I have planned for you today. Okay, so today, besides the fact that you guys didn't have time to finish the worksheet, which we will do in real time together, we will also look at some videos. The actual video that I talk about this topic is in 88 Tuition platform, which you're supposed to go and access yourself. But I have some videos that I pulled out from, of course, the best resource in the world right now that we know. Where is it from? Because there are many, but most common is YouTube. Easy to search, easy to find, easy to play. We all have the apps on our phone, so I do that the same. Let me go and quickly share that video that I wanted to show you guys. There'll be two videos, and then we will jump back into the questions. And when we finish the 10 questions, we'll do some extra questions, and you have time at the end. We'll also watch another 2 advanced lessons on YouTube. That means this knowledge is a little bit advanced, but because I'm going to have some time to play Kahoot with you guys at the end, where the quiz will be based on the video, so I will be able to show you some advanced knowledge on this topic as well. How many of you know what is osmosis? You know what is diffusion, but do you know what is osmosis? Okay, I'm going to write it down here for you. If you do, just put a thumbs up or say yes. Okay, if you don't, you're going to find out what osmosis is. It's very, very closely related to diffusion. But in the first place, you need to know what is diffusion, right? Diffusion, in a very classical explanation, we usually take the example of a smell. It could be a pleasant smell like a perfume, or it could be a very unpleasant smell like somebody just farted across somewhere. And then you can smell, right? Or if it's even somebody just sprayed perfume, you can smell as well. But that person doesn't need to be next to you. He can be very far away. And his smell, be it unpleasant or pleasant, can be smelt at your end. So that phenomenon of that smell is reaching you is actually because of diffusion. So you have these particles in a room. Let's say there's a room. Okay, and you are over here at the end. Okay, is that clear? And you have other particles which are air molecules which are present there already. So can I call this air molecules or air particles? It's the same. Okay? And then you spray a whiff of perfume at the other corner. Your mommy does it in her room. And you can smell it. Okay, what happens is, because they are all gas particles, they are moving, right? So what they're going to do is they're going to knock into these particles that are small in weight, and these weight particles are going to be moving to a new position. Can you see? So I remove one. Out of my 4 particles, one has moved along, and then I remove another one and moved along. So this is the process of diffusion, where the concentrated perfume particles will tend to move because they are all randomly moving anyway, and they collide, and they move from a region where they are concentrated. This is concentrated over here, to areas where they are not concentrated and end up at the other corner of the room, where suddenly you will be able to smell it. You see the 4 particles position right now? So this is basically the fundamental diffusion process caused by the random movement of particles, not only the concentrated particles, but the air particles that surround them as well. They do a lot of collision. Use this word, collision. See, okay, from the word collide, you can get the word collision. Okay, when they collide, means they meet each other, hit each other, they pass on the energy from one particle to the other, pushing them around, just like in any MRT, which is crowded, is full of people, and you actually don't want to move, but you get pushed by people who are moving. Do you get that idea? You actually don't want to move, but you get pushed by people who are moving. You are not the one. You just don't want to move, but you still end up slowly nudged to another end of the train or somewhere in the middle. That's what happens in diffusion because of the presence of other molecules. So, okay, so I hope I gave an intro. So now let's look at some videos so that the video will give you a visual representation of this. Okay. So let me just find out if I can go over there. Okay, I'm back. I guess that was enough intro to maybe try our questions right now. So let's share back the question paper itself. Right, here. Okay, thanks for Harvard for your answers as well. You've been trying to do them. I've got the answers. We will go through them. So let's look at question 1. Okay. So by virtue of you guys trying to put in an answer, we will figure out whether you understand what diffusion is. And diffusion is a very small part of particulate nature of matter topic. Actually, we have a lot more subtopics. Okay, so we are doing a very small subtopic only. So that's why I'm concentrating today's lesson on diffusion, where actually the particulate nature of matter is much bigger. Okay, later I will probably explain to you how big the topic is and how small this diffusion part is, and what other things that can we learn beyond diffusion, like when I mentioned osmosis and so on. So if you have an answer for each question, I will suggest you put it down on the chat, so that you can see you participating. So those who are not entering any answers, I can see you are probably drifting away from the class. So my very clear instruction is put in an answer. Which one do you think will be the final distribution of the bromine gas? Bromine has this color, okay? So in fact, if I wanted to write down the color, it's A is brown, and then air is colorless. So that's why in the diagram you're given as quite dark over here, and then air is given more or less as a white. White is not colorless, you guys know. So don't ever say air is white color. Air is not white color. Air is colorless. Yes, many of you, even after going through primary school, still make the mistake of saying, oh, what color is air? Air is white. Because you see here is white, but it's not. It's colorless, okay? Now, of course, the bromine will distribute itself to the bottom half and mix. Not in such a way where everything goes down and then nothing left. Okay, so there'll be even distribution across the two jars. Okay, so this is also out, right? B and D are out. Now we are left with A and C. In fact, right, to be absolutely accurate, do you know what I should do? It should be, if the color is like this, let me just see whether you guys are sharp enough to see what I've done. Okay. If you start off like that, the end product should be more or less. Okay, let me see. See who's going to be the first one to type what I've done. This one and this one. Why? What have I really done? Did I do something special, different from your question paper? In color, I can do this. In fact, in black and white also, I can. So later we discuss on what we can do with black and white. If it's in blue, what have I really done? Okay, the blue is not really intense in the second diagram, it's more distributed. Okay, so I would color it in such a way that the intensity of the blue is not so high, concentrated only in one half of the jar, because it managed to spread out. Okay. In a black and white diagram, we can also show that more like a grayish color if we wanted to. Okay. So that's not really, that's being a bit too accurate, but you don't have to bother with that. Okay. So now let's look at A and C. What do you think is the answer? I think many of you chose C, but I want to know why. Okay. The only difference they tried to trick you about here is this one. So in order to see whether that the little bit is shaded or not, you have to see at the start, you can figure out that this part of the jar cannot allow any gas to go in. It's just a kind of lid. The jar is only in the middle part. So therefore, the gas cannot be in the lid part. So this part is wrong, whereas here is correct. Okay. It's just the end of the two jars. So that part is just should be remain colorless. You shouldn't have gas entering that part, as we can see from the very first diagram. So this one became more or less like a spot the difference kind of a question, right? Spot the difference. Very close, but what's the difference between A and C? So very good. All of you did get the correct answer. Second one. Rate of diffusion. Okay, so how fast diffusion takes place. Always rate will refer to how fast, the speed or speed, right? Rate. These are the common definitions of rate. Rate, speed, how fast. How fast can diffusion take place if the temperature increases? Well, it's hotter, more energy. The particles will have more energy. If they can have more energy, they will move more. If they move more, they distribute more. If they distribute more, then they diffuse more. Diffuse is the action of moving from area of concentration to less area, to areas of less concentration. So this is the definition. If they want to move, they need energy. If you give them more energy, then they're going to move faster. So that's why faster. So they're going to go faster. Temperature is going to be a key ingredient. So what are the three ingredients we saw in the video earlier? Number one, okay, concentration gradient. The three factors that affect this diffusion rate will be concentration gradient, the temperature. This was, I think, was being stated in the video. I saw some of you taking notes, especially Chloe was taking notes as well. I'm sure you can see your notes right now, what you wrote just 5 minutes ago. Number three is the surface area, which the author or the narrator conveniently said we will look at it in a later. You know, when I think even in primary school, when we learn about whether oxygen can pass through our lungs to our body quickly, we talk about surface area of the lungs itself. Okay, more surface area, more particles can pass through faster. So that's why surface area is one of the determinants. Temperature is one, and concentration gradient. Concentration gradient means how much of a difference is there between the two concentrators, between the perfume site and the non-perfume site. Imagine I spray one time, there'll be a very small concentration of perfume. So it will move across quite slowly. But if I spray 10 times, the number of particles that I introduce, okay, if I spray 10 times, the number of particles I introduce also will be 10 times. Suddenly,